Hi, this is Abutamam Binuruddin. Today, this presentation is about the IT solutions for editor, where the editor is the process and the Arduino is used as a IoT device. So, moving to the next slide, here you see the table of contents. We have the introduction about the IoT system. We have the system descriptions about the IoT device and the implementation of Arduino as a IoT device, implementation of LabVIEW Linux, which is basically LabVIEW using Arduino to run the system, and ThinkSpeak as a cloud service or IoT cloud service, and a little bit about cybersecurity with the integration of IoT service. Moving on, here we have the introduction. As you know, the smart solutions for our daily necessities can be obtained by IoT applications, and most of the customers will look for the cheap and affordable things that is available as IoT applications that can make their life easy. And Arduino is a very cheap IoT device to implement several of IoT applications. Uh, uh, Controlling heating in a house is sometimes very important, and uh, Arduino implementation as an IT device can do it very cheaply and affordable to all the levels of the customers. Also, the data from IoT need to be stored um, for tracking analysis and see the customer, and so the customer can see if their application is working correctly or not. The ThinkSpeak is a good IoT cloud service for that and for managing the data. And IoT can this can increase the efficiency for the data storage also. So all of these can make a better editing solutions for the customers. Moving to the next slide, here we have the system descriptions. We can see the Arduino as a PI controller, which is sending signals to the air heater. But as Arduino is sending digital signals, air heater only receives the real air heater only receives the analog signal. So we have to convert that with the physical RC filter, so that air heater can receive signals, control signals to the from the Arduino. Then here we have the temperature sensor, which sends which detects the temperature, which detects the outflow of the temperature from the air heater, and we send it to the PI controller through a filtering sensor that reduces the noise from the temperature sensor, and PI controller uses the difference from the reference temperature and average temperature to send a better control signal to the air heater for running the air heater on the user references or user preferences, as you can say. Moving to the next slide, here we have the implementation of the system with Arduino. Here we have some codes blocks from the Arduino. Here we have the PI controller. Here we have the air heater. This is simulated. So we have simulated the air heater first, then tested on the real system. Here we have the low pass filter. And here we have the temperature sensor code that we read from the real air heater. So here is the implementation of the system. Here you can see the every time step, the control signal and the temperature set point. The air heater temperature set point set by the user, and air heater is trying to reach that set point. Here we have the set point. It is the reference temperature that's trying to reach the set point, and here is the control signal that's sent by the PI controller or Arduino. This system is implemented with the air heater, real air heater, and RC circuit and Arduino on the system on the real world to make it more affordable or make it more legible. Here we have the LabVIEW Linux. LabVIEW is a very good tool to visualize and control the data, control the things with different applications, and we can use LabVIEW in various operations to send signals to the cloud service to store it and very different applications. So we try to use the Arduino with LabVIEW. There is a special library for that. It is LabVIEW Linux, and this LabVIEW Linux this library Linux is used to control the Arduino and you use the Arduino to control the air heater. Here is the front panel of the applications, and here is the block diagram of the applications. Moving the next slide, here we have the LabVIEW Linux implemented on the real world. If you can see, this is the air heater, this is the RC circuit and the Arduino, and here we have the things that are getting. So the temperature, the reference, the Arduino LabVIEW applications, uh, the set this Arduino is trying to reach the reference temperature, but the as the graph shows, it's not a straight one, because in the lab Linux this process is very slow, and we didn't get a very good graph on the lab Linux, but compared to what we used in Arduino, but it is running on the real world, and it is hitting the air heater and try to reach on the uh, reference set point, but the process is really slow. Moving to the next slide, we have ThinkSpeaks as a IoT cloud service. So the ThinkSpeaks can serve as a data collection platform, allowing IoT devices like Arduino to send data to the cloud. We have data channels in ThinkSpeak that user can create and organize and manage. We have real-time updates on the ThinkSpeak. So when the application is running, it can update to the real time, and we can visualize that data with different graphs, plots, charts to make it easy to interpret. Also, we can use different codes to analyze the data for better implementing of the IoT devices. So I also the data that is stored that can create alerts and triggers for the IoT's applications, and it can be in from ThinkSpeaks. It can be integrated with lots of IoT services, and there are security measures for sharing, not sharing the data's, keeping the data safe, and keeping the data safe for the users. So ThinkSpeaks is a good IT cloud service. So we have implemented ThinkSpeaks also with Arduino in this little project. So here we have data from 2 days. One is from 20 September and is from 23, and both of the days the ThinkSpeaks stored the data very good. So here both of the days the temperature is every time the temperature is increasing to the set point, ThinkSpeaks recorded the data, and from this what user can track that if his application is running properly or not. He can see that is the temperature is getting close to what he desired, or if he's hitting the reference point, so he can know that his device is working very good. So it is a good way to visualize to the customer for his product. Also, we need cybersecurity for our system, because IoT devices collect and transmit lot of sensitive data. So cybersecurity is necessary for that data protection, and we need to stop unwanted or unauthorized users to see that data. So cybersecurity is also needed for that. That So also we need to ensure that the data is collected from IoT devices is not tampered with, so that people doesn't know what the data is and how to tamper with to manipulate the data actually. And protect against physical harm. We have to keep our IoT applications hidden to the users, that hidden to the other people's rather than the users. So it doesn't have any it doesn't cause any physical harm by different virus attacks or something. And also it is very important for business continuity, because if your data is not secured, then the business will people will not buy these things. Uh, so all of these things, I think cybersecurity is very important for IoT applications. And also in this application we have ThinkSpeaks, which is a very good cybersecurity, as you have to log in to see your data, and it cannot be easily tampered. No one can tamper easily with the easily with your data when you are storing data to the cloud of ThinkSpeaks. So this is all for today. Thank you for listening to this presentation.